So in this recording, we're going to be looking at a way of measuring angles, and this way is called the radian. So it's just slightly different to degrees. And you can see from page 13 on your log tables, it actually gives you a lot of the angles in radians. So you can work, it's just a different way of measuring them. So you can see you've got 0 for 0 degrees, pi over 2 for 90 degrees, pi for 180 degrees. And then if you went up to 360 degrees, it'll be 2 pi. So I'll just show you briefly where that comes from, and then we'll just work through some questions related to it. So if you look over here, we've got just a sector of a circle. Now the angle of that in radians would be the length of that arc there that's traced out in the circle divided by the radius. So you can see 1 radian then would be equal to, if that arc was equal to exactly a radius, then it would be 1 radian. And the reason for that is if we take that formula here, L over R, and we put it up here, so L over R is equal to, and in L in this case would be R, because we've made it the same as the radius for 1 radian. You can see R divided by R gives you 1, so that's where 1 radian comes from. Now, 180 degrees, two important ones to realize would be 180 degrees is equal to pi. And then 360, which is double that, is equal to 2 pi. So where that comes from is if you've the circumference of a circle, so we take theta, we'll take this for a full 360 degrees. So the formula for your length of your total circumference of this entire, so this whole circle going, the whole circle going around at this point, this entire circle here. If we took that, it'll be 2 pi R. So all I'm doing is just replacing L with 2 pi R, which is the formula for a total circumference. Divide that by R. That's equal to, the 2 R's cancel out, and you get 2 pi. So that's for 360 degrees. And just a new word that might be in there for you is subtended. So subtended just literally means that the arc that's traced out in the circle. So if they say the definition for a radian is the measure of an angle at the center of a circle subtended by an arc equal in length to the radius. So this just means subtended there. So now we'll look at a couple of questions related to that. So our first question A, express 3 pi over 5 degrees radians in degrees. So 3 pi over 5. Now it's just important to note that pi is equal to 180 degrees. So all we want to do, if we want to convert that into radians, we just simply replace pi with 180. So you can see we've got 5 into 180 goes 36 times, we get 3 times 36, and that will give us 108. So for our second question here, we're going to convert 280 degrees to radians. So for this one, it's important to note that, like earlier, pi is equal to 180 degrees. Now, that will allow us to find out what is 1 degree in radians. So if you were to divide this by 180 to get 1, you'd get pi. So you need to divide both sides by 180. So pi will get divided by 180, and that'll be equal to 180 divided by 180, which gives you 1 degree. So 1 degree is equal to pi over 180. So in that case, if you want to get 280 degrees, all you have to do is just multiply this one by 280. So it's always going to be pi over 180 for 1 degree. So for that case there, you take 280, multiply it by pi over 180 degrees, and then simplify that, and that should all simplify down to L. If you divide so you can cross out the zeros first of all, divide them both by 10, and then if you divide them both by 2, and we can see, can we break it down any further than that then, 14 pi over 9, and we can't actually break that down further. So that is 280 degrees in radians. So for the next question, the radius of a circle is 10 centimeters. So you can see I've just indicated that down in this circle here. Find the angle at the center of the circle subtended, so that's measured across, by an arc of length 15. So we'll just fill in that information there. So we're going to put in 15 on this one. And we're trying to find theta. So remember earlier on, our formula for our theta degrees in radians will be L divided by R. So in this case here, we have L and R, so we can just fill them in. So L and R, L will be 15, the arc around the outside, R is 10, and then that is going to be equal to our theta. So all we do is literally just figure it out there. It's 15 over 10, divide the top by 5, bottom by 5, you get 3 over 2. So for this next example, we're going to get pi over 5 is the angle in the center. So find the length of the arc if the angle subtended at the center is pi over 5. So that's pi over 5. Our radius is 10 and we're trying to find L. We don't know what that is. So we're just going to take our same formula, pi. So this is part 2. Pi is going to be equal to L divided by R. And we just fill in everything. So we have our angle, pi over 5 is equal to L, which we don't have, and then we have our radius, which is 10. So we're going to cross multiply, you get 5L, so 5 by L is equal to pi by 10, so 10 pi. And you can see that then simplifies if we divide both sides by 5, so 5 and 5 goes once, we get L on its own. So L is going to be equal to 5 pi. So that's that distance there. And you could simplify it or just leave it as 5 pi.